Good afternoon. Welcome to the third session on air pollution control engineering course. So, in today's session, we will discuss about some two special topics on air quality management. One, air pollution and climate change. The other one, low cost sensors in personal exposure monitoring. So, these two are the recent topics that are important in air quality management. So I thought I'll just share a video to connect it all the things, but anyway I'll just make upload this particular video separately, which give you a complete picture of how different sources contributing from various anthropogenic activities can relate it to climate change. So all of us know that the Earth temperature is increasing. So a study indicated that about 1 degree centigrade has been increased over a last decade. There is a stronger evidence which indicates that last 50 years there is a more warming is happening just because increase in human activities. So they conclude that human activities alter the chemical composition of the atmosphere. So hence there is a increase in greenhouse gases such as carbon dioxide, methane, oxides of nitrogen. So eating is generally, if you try to look at here, so there is a incoming solar radiation that will be coming to the Earth's surface. Some of these greenhouse gases, they trap the outgoing radiations. So this trapping resulting into more warming. So particularly many of the anthropogenic activities, including emissions contributed by industries and vehicles that are altered the compositions of the greenhouse gases in the ambient environment. Okay, so this gives some more information. In particular, the gases such as water vapor, carbon dioxide, methane, chlorofluorocarbon are capable of absorbing the terrestrial radiations. Then hence some of this radiation going back from the Earth's surface will be trapped. So hence this resulting into increase in surface temperature. So just like in your glass chamber, so you see that all the gases which are releasing from the gas won't allow whatever the heat which is trapped, hence the whole mechanism can be related to a greenhouse gas, is similar to greenhouse. So in the important greenhouse gas among them is CO2. The main suspect which thinking that there is an increase in temperature just because increase in CO2 emissions due to various anthropogenic activities, in particular fossil fuel combustion. Some of the facts you must be aware of it, which country or which state can contribute more CO2 emissions. All of us aware that developed countries sometimes are generally contribute more CO2 emissions when compared to the developing countries. So if you try to look at a UK with a population even close to 60 million emits more CO2 than Egypt, Nigeria, Pakistan, Vietnam with total population of 472 million. So it means that even if you try to look at in developed countries, per person CO2 emission is much higher than compared to developing countries. A state like Texas with a population 23 also contribute significant CO2 emissions than an African country. So it means that urban area in developed countries contribute significant CO2 emissions. If you try to recollect one of the chart which I presented in the session 1, which indicates that the CO2 composition in the ambient environment is 315 ppm. Now if you try to look at in 2002, 2007, the measurement indicated there was a 383 ppm. So it means that there is a significant increase in CO2 concentrations in the ambient environment. Now, what are the indicators for this global warming? So you know that ambient air temperature near surface increases. So all of us are aware of it. There is an increase in surface temperature. Then humidity is also increases. Then temperature over ocean also increases. Sea surface temperature increases. Sea level rise is happening. Then temperature over the land area increases. So there are some things which is decreasing. Ice in the sea will be reduces. Ocean heat content is also increases. The snow cover is melting because then it is decreases. Glaciers, again, lot of area which is glaciers were available, they are also reducing. So if you try to look at the mapping of the global temperature index with the ocean in temperature index, if it sees that there is a significant match with over the years. Now, what are the consequences we can expect because of global warming? So sea level rise, so beach erosion, coastal wetland loss of low-lying territories. Then with respect to water resources change, precipitation pattern shift, some of the things happening in many countries where drought and floods are happening just because of are linking to the climate change. Increase instances of heavy precipitation, for example, Chennai flood, flood in Mumbai can also linked with climate change aspects. New burdens on water capture, storage and distribution system can be expected. And effects on agriculture, as the result of this precipitation pattern, there is a possibility of changes in length of growing season, growth of undesirable plant species. These are all some things can be related to global warming. Now, since we would also like to bring your attention how this climate change can be linked to an air quality. So increase in reaction rate and concentration of certain atmospheric species can happen because of change in temperature. For example, the ozone formation can increase with increase in urban warming. So more droughts, widespread of forest fires, worsen air quality. Change in how pollutants are dispersed. So as the temperature pattern changes, there is a possibility of the pollutant dispersion within a given area. Coming to impact on human health, changes in pattern of sickness and death, respiratory problems affected by air quality changes, this can relate it to human health. Coming to biodiversity, some species may grow too quick and overshoot their reproductive periods. So sometimes in reef corals, so this can happen. Then forest could be devastated if the rate of climate change outpaced the rate at which the forest species could migrate. So this is another issue. There is a forest can be devastated with the increase in climate change with global warming. Then change in pattern of ocean current, this can also changes. Now coming to a linking of climate change with air pollution. As we all know that climate change and air pollutants share a common source, like anthropogenic sources contribute to air pollutants and in turn pollutants can affect climate change. So air pollutants act as a greenhouse gases too. So change in climate also affecting on air quality. That's what in the previous slide I mentioned. Suppose increase in temperature can also affecting on ozone formation and also secondary particulate formations. So these pictures give you some informations. There are different emissions that are linked to a climate change. For example, oxides of nitrogen, particulate matter, these things can, and also volatile organic carbons and methane, they can all link into a climate forces. So in turn, they are also affecting on air quality. For example, some of these pollutants also enhances ground level ozone concentration and also form some of the secondary particulate formations. So the climate force in turn will affect on human health, ecosystem and climate. So coming to the complex relations and trade-offs. For example, if you try to look, we were looking for beneficial for air quality and also beneficial for climate change. So what factors, how we can relate that? So for example, if it is a beneficial for climate change and beneficial for air quality, we should look for energy efficiency, demand management. It means that we should go for more nuclear power based energies systems, then wind and solar. These are the technologies we should use for energy production. So then there will be a less air emissions because of this activity. So that is good for air quality, also good for climate change. What is the worst one? The worst is, okay, there is a more energy demand, more use of coal, oil, fuels. So hence it is bad for climate change, bad for air quality. So we are somewhere here. So we are also using some aspects of controls which uses emissions. So which will affecting some aspect to the climate change, but it is negative in terms of air quality. There are some pollutants which are particularly of interest relating to the climate change. One is oxides of nitrogen, which is basically comes from power plant and also vehicle emissions. So oxides of nitrogen takes a very important role in formation of ozone. Then it also contributing to the acid rain. Now there is a interesting research going on how to link some of these pollutants to visibility. So sometimes the visibility reduction can increase with increase in participation of oxides of nitrogen. There is a significant contribution of N2O in global warming, which is 300 times more dangerous than CO2. NOx also participate in secondary particulate, so which means that finer particles concentrations can also increases. These NOx concentrations can also a long transported, means whatever they are contributing here, that somewhere else it can resulting into secondary formation or secondary particulate formation or visibility impact. It means that it can be a regional problem or continental problem. So coming to impacts on health and vegetation. So as you know that because of the urban warming can resulting into more ozone formation, and that's why you will noticing that these days more number of cities are showing increase in ozone concentrations. Okay, so ozone is a powerful oxidant that can irritate, means it can affecting on your respiratory system. Inflammations can also happen. It affects on plants, browning of leaves and decrease in photosynthesis activity. So these are all some of the impacts you can expect by increase in ozone concentration. Then air pollution and climate change with respect to particulate matter. So finer particulates, as you know that the particles are more finer, it will offers more surface area. Some of the polyaromatic hydrocarbons, metals can attach to these finer particles. In turn, they can get into your respiratory system. If here I have showed a size of an air which we are ranging from 50 to 70 micron. We have two types of standards for particulates pollutants management, PM10 concentration where the particle size diameter less than 10 micron and PM 2.5 micron standards that will be where the particulates of diameter less than 2.5 microns. Now the other aspect which is important with respect to climate change is urban areas contribute significant concentration of CO2. If you use any fuel, if it is a complete combustion happens, it will resulting into water vapor and carbon dioxide. Okay, so there is a information which states that there is a 31% increase in CO2 concentrations. Then motor vehicles are the main sources of air pollution. In fact, CO2 is also significantly contributed by motor vehicles. CO2 emissions combined with change in urban land use. For example, if you try to take a central business district where the land use is completely changed in terms of the green cover, the building height, the air circulation that is happening, we can relate it something called ventilation coefficient. Ventilation in that area is altered because of the change in land use. As a result, more number of vehicles will be there in the central business district, hence there is a more amount of CO2 emissions in central business district. As a result, the more CO2 emissions, there is a more heat trap in that particular area, because any fuel combustion resulting into carbon dioxide and water vapor. So there is a possibility of more humidity and CO2 both trap the heat. Hence, you will going to see more warming in central business district. This phenomena we call it as an urban heat island or UHI. Urban warming is hazardous for urban dwellers, especially people who are residing in those locations. It is much more hazardous. So the heat stress related illness and increased ozone formation both are significant in those areas. This is also linked. For example, you also notice that is there any linkage between CO2 emissions, that is urban heat island effect, and the scarcity of water? Yes, there is some linkage. So if you look at it, if the rising temperature happens because of increase in CO2 concentration in the urban area, as a result the temperature, the ground level temperature increases, hence the evapotranspiration rate is also increases. Hence you also notice that there is a more water will get evaporated, hence water scarcity can link to increase in temperature and CO2 emissions in the urban area. The air pollutants, as I mentioned to you, there is another aspect of visibility. So if you try to look at more secondary pollutants can reduces the visibility. Okay, this is another aspect with respect to climate change. So some of the factors which affecting visibility is the size fraction. If you try to look at it, the smaller size significantly affects visibility. It means that if you look at the combustion related particulate matter, the size range will be less than 2.5 microns. Hence, the size of particulate matter also affects significantly on the visibility. The mechanism of light interaction, scattering or absorption, that is also affecting on visibility. Then the speciations, the absorbing species and scattering species, for example, black carbon. So these also affecting the visibility in that particular area. Now I'll move on to the other topic which link about low cost sensors in personal exposure monitoring. Let us try to understand. Under National Ambient Air Quality Monitoring Program, we have about at present 573 ambient air quality monitoring stations across the country in 240 cities and 26 states and 5 union territories. So this pictures gives some of the data which indicates the number of monitoring stations that are being operating to characterize the air quality in different parts of the country. So for example, in Tamil Nadu we have about 22 ambient air quality monitoring stations. In Delhi we have about 8 ambient air quality monitoring stations. So these air quality monitoring stations data have been used to characterize the air quality in different places. It is also projected that by 2020 they will also increase the air quality monitoring stations by 1,000. Now there are issues associated with that. So for example, how many stations we need to be set up in one area? For example, a city with population about 50 lakhs, then how many stations should be there? So EPA has made some guidelines. So there should be one air quality monitoring stations for every 5 lakh population. It means that, so if the population of the city is about 50 lakhs, then you require about 10 monitoring stations. So each monitoring stations is very expensive because all these monitoring stations involves integration of a sophisticated air quality monitoring instrumentation, both for measuring gaseous and particulate pollutants. So hence the more number of monitoring station requirement increases the capital investment. So this is an example for a stationary monitoring network. You will going to use high volume samplers. Sometimes they will be use a sophisticated instrumentation at a fixed place to capture the air quality. You also have some cities, they also have a mobile air quality monitoring stations where the same set of a sophisticated instrumentation has been placed in a mobile van and it will be moved to different places and record the air quality. Okay. So the combination of these two will give you a spatial and temporal variation of air quality at a particular location. Out of this air quality data, the data has been used to declare the 72 cities in 23 states have been declared as a non-attainment area. Now if you try to look at the 72 cities in India where the air quality is not meeting the requirement as per the Central Pollution Control Board investigation. So which clearly indicates that whatever the standards we have, national ambient air quality standards we have, so these 72 cities in 23 states are not meeting their requirement. Out of these 64 cities, the respirable suspended particulate matter values are exceeding the national ambient air quality standards. Okay. And 56 cities suspended particulate matter exceeding national ambient air quality standards. So now if you try to look at suspended particulate matter has been replaced, now it is still it is being used in industrial emissions measurement, industrial air quality measurement, but in urban area we have now only with the two standards, one is PM10 and PM2.5. Okay. So respirable suspended particulate matter is equal to PM10 and PM2.5 is particulates of size range less than 2.5 micron. In some places even NO2 concentrations also showed violation. About 9 cities the NO2 concentrations are violating. Now the question comes here, the air quality and the source contributions are very important. You need to understand, okay, which source is contributing, which area the air quality is very bad. So in this direction, the number of monitoring station, the time duration of measurements and delineating these areas will be important for urban air quality management. So in this context, since as I mentioned to you, each of these sophisticated air quality monitoring stations, for example, I mentioned in the lecture session 1, there are different types of equipments that can be used for measuring source emission as well as ambient emissions. So we have two types of standards, emission standards for the source and also ambient standards for ambient air quality management. So now if you want to set up more stations, for example, in a city of population about 50 lakhs, you need to have about 10 monitoring stations. So then one of the questions comes to you, where to locate these monitoring stations. If you try to look at the standards are specified for two areas. One standard is meant for residential, industrial and traffic sites. The other one is ecologically sensitive areas. Now you can identify such locations within the urban area and decide to how many such stations should be there in a particular city. Now the question comes here, if you put a station, each station has some limitations. So any of these sophisticated monitoring stations will have a coverage of up to 500 meters. So any monitoring stations which you set up will able to capture an information up to 500 meters. If it goes beyond 500 meters, then probably because of the wind pattern, the geometry, land use, all those effects, and it may not really reflecting the air quality beyond 500 meters. So it means that a city area of about several hundred kilometers, so how to distribute these number of monitoring stations will be unquestionable. In order to meet that, so people research are going towards understanding and trying to bring out the low cost sensors to complementing to the existing monitoring stations. So we at IIT Madras, we are also trying to develop a low cost sensor based air quality monitoring network which can complementing to the existing monitoring network for air quality assessment. If you try to look at Chennai, so we have an area about 175 square kilometer. So within that 175 square kilometer, at present we have about the the more than 3 continuous ambient air quality monitoring stations run by Central Pollution Control Board and few ambient air quality monitoring stations run by Tamil Nadu State Pollution Control Board. Now, in order to bring out the spatial distribution of air quality, we have set up a low cost sensor based network. What we are trying to do currently, the research in progress is we are trying to put a low cost sensors on bus, on bicycle, by walk, and try to understand how the low cost sensors capture the spatial and temporal distribution of air pollutants contributed by various activities. So this picture shows one of the such exercise where we have installed a low cost sensors on a bus which moved through different directions to capture the air quality. So this indicates a small portable low cost sensors which uses Arduino board and different sensors which we have integrated which works with a battery, and there is a small flow arrangement, and it captures the carbon dioxide, carbon monoxide, temperature, humidity, ozone and oxides of nitrogen and particulate matter concentrations. So the particulate matter concentrations even gives some different bins. It means that ranging from 0.3 micron to up to 10 micron. So these sensors, there are some issues associated with these sensors. We need to be calibrate that these sensors are, since they are low cost sensors. There are 2 types of low cost sensors. You can use a semiconductor based low cost sensor or electrochemical based low cost sensors. So you can use them for air quality measurements. So one of the issues is you need to be calibrate them. You need to be co-locate with either a sophisticated monitoring station and try to understand what is an accuracy of these low cost sensors, how their measurements vary with respect to the time and also with respect to the activity. So we have a small setup in the lab where we have a small gas chamber where we use the different dilutions to calibrate some of these low cost sensors. We also have a humidity chamber to calibrate humidity and temperature sensors. So we use one of the, this graph gives a quick measurement of air quality low cost sensors which you used for traffic emissions measurement in one of the road in Chennai city. So it will give an indications that on different time periods what is the carbon monoxide concentrations during morning and afternoon and evening. So you can able to even identify the congestion pattern and you can indicate what is an air quality, and this gives an idea for the entire stretch. If you try to look at and this area there is a possibility of a small congestion. So you can link it to and addressing that there may be a possibility of traffic congestion at this particular point. So there is a possibility of using these low cost sensors, placing them in a different road network. Maybe you can use electric poles to place these sensors. In addition, you are keeping in the vehicle itself. So this will capture a large spatial variability of the pollutant concentrations. They can transmit these informations, in turn will give you a better informations related to air quality distribution of a given area. So this is some of the pictures shows this has been installed in some of the places within close to IIT Madras. Now coming to since this became a tool for a personal exposure, because these are a very small type of air pollutants measuring instruments, so it can be used just like your mobile phone. People can carry that, and then you can also use for personal exposure. Basically, now we are using the earlier most of the data in health risk assessment. They used stationary air quality data. So as I told you, the stationary air quality data sometimes underestimate the exposure aspect, because you know that the people spend time in different environment, different micro environment during the day. So for example, majority of us will spend in the indoor environment and only about 20% maybe we will spend outside. So it means that now if you relate it, a stationary air quality station which gives an information and try to relate it the health risk which sometimes underestimate. So in such cases this low cost sensors informations complementing to the your stationary air quality monitoring will be beneficial. So existing air quality health risk assessment, that's what I mentioned to you, fixed site monitoring do not take into account of pollution hotspots. Sometime within the urban area, you will notice that there are many hotspots, and if you notice, the air quality will be much more higher in those hotspots when compared to the other areas. So hence, so when your people spend more time on such hotspots, then it will be a much health risk associated than people who are spending in much cleaner environment. So personal exposure measurements refers to the pollutant concentration measurement at breathing level. So now if you try to look at most of the existing monitoring stations, the measurement will be made at 10 meter height or maybe at 3 meter height. So now at ground level, for example, vehicular emissions. So vehicular emissions will be released at a height of, cars are releasing about 30 centimeter and buses will be releasing between 1 to 1.2 meter. So the exposure at 1.5 meter because of this low level emission sources will be significant when you are measuring the emissions at 3 meter height. So hence the personal exposure instruments like low cost instrument can also beneficial even to capture the personal exposure. So you can use this personal exposure for hotspot identification, air quality mapping and also exposure assessment. Now I'll try to link all these things in coming slides. So first try to understand what is air pollution hotspot, a location where emissions from specific sources may expose individual and population groups to an elevated risks of adverse health. It means that a specific source can cause a significant damage to an individual or group of population. For example, a street canyon and a busy traffic road, on both sides you have a tall buildings, then all the pollutants released by these movement of vehicles will trapped, and people who are residing in this area will be exposing to the higher pollutant concentrations. For example, people who have residential apartments very close to the roads, they will have significant air pollution issues. Then industrial clusters, where the emissions will be significantly contributed, residential area located very close to an industrial area can be an hotspot. Then open dumping, open burning is another hotspot where if frequent fires, if it catches, then a significant amount of emissions also contributed by dump sites. So this gives some information to you. So we have made a real-time estimation to indicate that how pollutants changes with respect to time. Now if you try to look at this and the time scale, on these two spots the air quality will be significantly higher irrespective of time. It only indicates that during the, it indicates that a location of two power plant emissions, stack emissions at this particular location. Now coming to the other areas, now if you try to look at around 8 to 9, then mostly the air quality will become, the emissions will become red, and again around 4 and 5 the emissions will become red. It only indicates that there are more number of roads, more traffic will be there, hence more emissions. So it only indicates a traffic emissions will be significant during a morning peak hour and evening peak hour. Now you can use this information. Now you have an emission factor. Emission factor have been used to quantify the emissions contributed by different activities that can be linked to your modeling. So the model will able to explain the type of the contributions that is happening. Now in this case I have set up an AirMod model, which is an EPA model for assessment of air quality. So now the emissions in the previous slides, the real-time emissions that are contributed have been integrated into the model. Here also we have considered a significant number of roads within the Chennai city, and we have quantified the emissions contributed by each roads, and that have been integrated into the model. In fact, this on your left side shows a real-time traffic measurement using a video camera, then followed by manual counting. There are some softwares that are also available based on the vehicle movement, the shape and size. You can also quantify number of vehicles that are available in a particular stretch of road. So these emission estimations, now I would like to recollect the emission equations which we have used in the session 1, which indicates that emission factor multiplied by the activity. So here the activity is the vehicle movement. So you have a different types of vehicles. You can use within the different types of vehicles, they are of different age groups. So you can use a corresponding emission factors to quantify the emissions contributed by this number of vehicles. Okay, so that informations have been integrated into the model. Now, if you try to look at, if you see that any website, it only indicates, like earlier slide I mentioned that the air quality out of many cities, about 73 cities, the air quality is very bad. They are declared as non-attainment area. Now the one question comes to us, is the air quality across the city is very bad? Is that air quality in selected location it is very bad? Okay, so it means that if you do a modeling exercise, or if you do a measurements using your low cost sensors, because now if you try to look at, I have set up an air quality monitoring stations here, one more year, one more year, one more year. So what will happen? In this place there is a, if you try to look at with respect to emission estimation, the air quality will be generally good here. And if I set up here, the air quality will be always shows it is alarming. If I set up here air quality monitoring station, it always says alarming. So it means that whatever the informations which we are captured with our ambient air quality monitoring stations will not represent the air quality of the entire city. So that is why you need to have a combination of a low cost sensors based monitoring network and also a sophisticated monitoring network. In addition, if you use the modeling system, the modeling system will help you in delineating some of these air quality control regions. Now if you try to look at, now I mentioned in the earlier slide, the Chennai city with respect to particulate pollution is been declared as non-attainment area. It means that in Chennai city, the PM pollution levels are not meeting the national ambient air quality standards. So the national ambient air quality standards for PM10 is 100 microgram per meter cube and PM 2.5 is 60 microgram per meter cube. It means that if you do a 24-hour average monitoring, the values of PM10 and 2.5 are always, most of the time it is exceeding. Now question comes, is that air quality for the entire city is exceeding, or is it only some places it is exceeding? So in that context, we have developed a modeling system. We have used a air mod to predict the air quality across the city. Now if you try to look at, instead of the whole city, and even in this emission estimation also indicates not the whole city the air quality is not bad. So you only notice that these two places, the emissions, I am not talking about here the air quality, the emissions are here significant. Wherever there is a red spot patches, the emissions are significant only few hours of the day. So it means that those are some of the sources that contribute significantly, and if you try to measure the air quality across these areas, they may be significantly higher. So with reference to that, this gives some informations on air quality which are higher than standards. Here if you try to look at, there are red spots indicate the air quality is generally higher when compared to other regions. So if you try to look at, there are some 10 to 15 locations, the air quality is very bad when compared to all other areas. So it means that within the city you can delineate the air quality control regions, and in turn you can focus on addressing these air quality control regions in order to improve the air quality. Now we also made some attempt to understand how this traffic congestion will increases the air pollutants. So this is again a Sardar Patel route where in Chennai city. Then if you try to look at different time sequence, the concentrations how it is varying. So this is a real-time exhaust emission measurements. All of us know that more stop and go operation, like a more brake, applying a brake and acceleration, deceleration involves more amount of emissions. So we are trying to develop a real-time emission prediction model, and if that can integrate it to engine operation, then you will able to notice that and which location the air pollutant concentrations are significantly higher and which time period the concentrations will be higher. So it will give even an informations for the decision maker in terms of regulating the traffic, and also if this model can also be integrated into the vehicles, then vehicles, the driver can also get a feedback on how they are driving the particular vehicle. So this will be another direction for improving the air quality. Now if you try to look at, we have used those test corridor very close to our IIT Madras major roads which are available here. So we used we have used exhaust emissions as well as ambient fine particulate measuring instruments. We have moved with a bus, car, and also by auto rickshaws. So they were able to indicate which are the locations the air quality will be very high. So this gives even an hotspots where the air quality is comparatively higher when compared to the other locations within the test corridor we have considered. So these are all some of the hotspots which we have indicated. Now coming to the hotspots air quality measurement, as a part of one of the research work we have sponsored by Indo-German Center for Sustainability, we did an assessment of air quality at an industrial area, commercial site and dump site and background site. Now if you try to look at Manali with a population of about 35,000 and a commercial site with a population of 1,52,000, and in the dump site as a where Perungudi dump site, there is an adjacent residential area which is also a population close to 40,000. And we also compared the air quality within our campus with which is having a population about 15,000. Now we also made some comparison with respect to Indian city with one of the German city Leipzig, and we used sophisticated instruments for measuring the particulate pollutants, which is one of the concern in both in Chennai and as well as in Leipzig. So we did a measurements at different places, a commercial site, residential site, and also this dump site and background site. If you try to look at within the a commercial site, we have selected a stretch which a significant of traffic and an area which is dominated by residential activity and an area dominated by commercial activity. So this is the length of the road. Traffic side is about 900 meters, residential side is about 520 meters, a commercial site is about 700 meters. So we did a measurements again at 3 different time periods, morning, afternoon and evening, and try to use it. This gives an average concentration, and you notice that a traffic side has a concentration varying from 60 microgram per meter cube with a standard deviation about 13 microgram per meter cube. So the mean exposure time is about 20 minutes, and that is the time duration people like the experiment took from walking from one location to the other location in that site. Then coming to the residential side, it's about 520 meter length. So an average concentration exposure was 45.4, deviation of 15 with an exposure time of 8. And coming to a commercial site, again length about 700 meters, and concentration is 63.26 and with a standard deviation of 23. So again the exposure time is 12. So now you will come to a conclusion that concentrations at a commercial site where number of vehicles and also the movement of two-wheelers and auto rickshaws might have been resulting in significant contributions in that particular area. Now coming to an industrial area, if you try to see that again, we did an exercise morning and afternoon, evening with a known stretch of road, and this side there is a residential, this is an traffic where significant movement of vehicles, and these two are industry closer to the industry. These roads are closer to the industry. Now in the morning PM10, 2.5, PM1 concentrations, if you try to look at an average, so in this case we have made an average for all the things. So morning time the concentrations ranged about 120 microgram per meter cube for PM10, and PM2.5 60 microgram per meter cube, PM1 30 microgram per meter cube. So you'll notice that about 60% or about 50% of the concentration is less than 2.5 micron. It means that significant amount of pollution also contributed by other than combustion activity. If you recollect, the particles contributing from combustion activity will be less than 2.5 micron. In the afternoon, the concentrations were about close to 100 microgram per meter cube. In the evening, again it is 126 microgram per meter cube. Now you can relate it, the meteorology influence of meteorology. So in the afternoon, because of increase in mixing height and also because of a possibility of sea breeze, there is a chances of more dilutions. In the morning and evening, because of the stagnation of air or inversion conditions, could have been increased the particulates concentrations in both the time periods. In addition, the morning traffic which are significant in these areas because the people working in the industries coming to the office, and also in the evening they are leaving the office, also might have been contributed in the morning and evening PM levels. So similar observations were made in PM 2.5 and PM 1 concentrations. So this gives an information on emissions contributed by a dump site. We made again a similar exercise carrying these instruments across the dump site and also within the dump site. And as you notice that wherever there is a possibility of some emissions or because of a fire or because of the movement of the vehicle, we notice there is a significant emissions certain locations within the dump site. And interestingly, there is significant concentrations in nearby residential area. So we also made a comparison of these PM concentrations which we have measured with Chennai city and also with Leipzig. Now if you try to look at, we did a same exercise measuring PM concentrations in Leipzig and Chennai city, morning, evening and afternoon. So I'll just give one quick informations to you. If you have an air conditioned room, what could be the particulates concentrations you can expect? So the particulates concentration you can expect in an air conditioned room will be less than 15 microgram per meter cube. And if it is a naturally ventilated room, for example, if it is your home, you will expect about 20 to 25 microgram per meter cube. If there is a cooking activity and there is a sweeping or some resuspension, then this concentration go up to 30 to 40 microgram per meter cube. Now look at this. In this case, the Leipzig, the particulates concentrations varying between 22 to 23 microgram per meter cube even in morning and afternoon, and evening even because sometimes the wind is so good, even it reduces the concentrations up to 7 microgram per meter cube. Now coming to our city, the Chennai, so where in the morning concentration it went up to 75 microgram per meter cube, and if you recollect, the PM standard says is 60 microgram per meter cube. That's why it is violating. The afternoon concentrations are much less, say around compared to the evening or morning in the morning. And in this case also we have noticed a significant less evening concentration, probably because of there is a dispersion or maybe some rain event might have been occurred during that period. So in summary, the Leipzig an average concentrations is about 19.15 microgram per meter cube. In Chennai, the average concentration is about 56.63 microgram per meter cube. Now these informations you can use it for frequency distribution. Now you can look at it in this with respect to Leipzig, and you will notice that the majority of the concentrations will be within the 20 to 20 microgram per meter cube. So this is the size range now concentration range you will going to get, mostly it will be dominated. So sometime the concentration even went up to 50 microgram per meter cube. But now if you try to look at our Chennai city, the concentrations were much more dominating between 40 to 60 or 70 microgram per meter cube. That's where number of cases were more. So even some occasion, even you will notice that concentrations exceeded 200 microgram per meter cube. This can happen just because of some exhaust when we are carrying the instruments and the exhaust emissions exactly coming and hitting the sampling probe, you will pick up that higher concentrations. Now, what is the way forward? How to improve the air quality? That's the questions we need to be addressed. So one, if you try to recollect from the first session lecture, so there are majority of the emissions contributed in the urban environment is vehicles. About 70%, 60 to 70% of the emissions are contribution is from vehicles. Now, how to reduce those emissions? In fact, vehicle emissions also linked to climate change. Then how to link them? So, what is the new deal for transport? So, the local transport plan. So, you can think of a local transport plan. So, first you should tackle a traffic congestion. So, if you try to recollect some of the, which indicates that not the whole city, the air quality is very bad, and you also notice that the whole city is not congested. Some of the major roads, the traffic congestion will be there. So you can try to look at how can we reduce the traffic congestions in those areas. And delivering accessibility. If it is a congestion, then see that how we can increase the accessibility there. You also ensure safer roads. In traffic plan or local transport plan, we never discussed about better air quality. So maybe we should try to bring some informations related to how air quality can be included even in a transport policies. In order to do that, you should look for alternatives to the car, and you know that earlier in the urban areas there used to be more emissions or more number of vehicles. Two-wheelers used to be more, then followed by cars, and then all auto rickshaws and heavy-duty vehicles. But now what's happening is more number of cars, and cars percentage in some cases, even when we do an analysis from weekdays to weekends, the number of cars are increasing on weekends and when compared to the two-wheelers. So it means that we need to look for alternative to the cars. Then we also should look for a smarter travel. So it means that we should reduce travel and also better mode for smarter travel. Demand for management. Okay, so if it is a more frequent travel requirement is there in a particular area, then you should plan for mass transport system. Then air quality action plan. So now if you try to look at in some of the areas which we have indicated, there air quality is significantly higher, then you can look for how to reduce the emissions by bringing out the action plans only at that particular area. For example, if you try to look at now current approach for air quality management is city level. So we try to bring a policy to improve the air quality at the city level. But if you try to recollect in the last slide, then you will notice that air quality in a few locations will be very bad. Then a city level policy will not be effective in reduce the emissions at the local level. So you need to have a local level air quality management plan. So in such cases, so you should have an air quality action plan at that particular area. For example,